Hi there everyone, today we're going to look at solving simultaneous equations. We're going to do it in two stages. So this particular lesson is all about elimination. So we're trying to eliminate a variable in order to help us kind of solve two sets of simultaneous equations where each independently can't be done. So you need two equations that we're able to solve it. Alright, so simultaneous equations have two unknowns, which effectively normally it's an x and a y, but of course it doesn't need to be. But individually they can't be solved, but we obviously have two. It allows me to kind of solve them. So if both equations have a term with the same coefficient, you can subtract one equation from the other. All right, thereby eliminating one. So what we're going to look at is what that in essence actually means. So when we're talking about a coefficient, we're talking about a number that's in front. All right, so hopefully you can see from here, these two numbers here in front of the y's are both exactly the same, and they're both plus as well. All right, so what we're suggesting here is that if I take away this bottom equation from this top equation, that one take away that one would leave me 2x, but this 3y take away this 3y would disappear, it would be eliminated, hence the terminology, and then you'll end up with 18 take away 12. Right, so by doing that kind of process, you are eliminating one of the variables and therefore enables me to kind of find one of the values. All right, so let's do that. So let's label them 1 and 2, and it tends to be a technique that most people use, so you can explain to whoever it is that's looking at it what it is that you are doing. You are going to do 1 take away 2, all right, to eliminate y. All right, so when I do 1 take away 2, like I mentioned, you're doing 5x take away 3x, which gives you 2x. The 3y's will disappear, and 18 take away 12 leaves me 6, so therefore 2x is equal to 6. So solving a simple equation like this, divided both sides by 2, x is equal to 3. All right, so you've got one variable. But you're not quite done, because if I'm going to sort of solve a pair of simultaneous equations, I'm not just looking for the x value, I'm also looking for the y value. So because I've got 1, I'm then going to substitute this value of 3 into either of these two equations, either of them. All right, the one that involves an x and a y, by the way. So either of these two, so you can choose. So now sub into one of the equations. So normally pick the easiest one. It doesn't really make a difference. So we're going to go for the top one. So 5 times 3, because we know x is 3, plus 3y equals 18. So there you go. 5 times 3 plus 3y equals 18. So that means 15 plus 3y equals 18. Take away the 15 from both sides. So 3y equals 3. Therefore, y is equal to 1. All right, and you can see from there that that is my solution. You've got x equals 3 and y equals 1. And that's going to be answer. I have solved that equation to find the two unknowns. Now, if I put x equals 3 and y equals 1 into both these equations, then you should end up finding that they both have 18 and 12. And of course, you can double check that if you wish to make sure that is the case, but I assure you it is. Okay, let's look at another example where these numbers are different. All right, because if I do one take away the other, in this case, because the coefficients of the 6 and the 2 and the 5 and 2 are not the same, then they're not going to be eliminated at all when I do one take away the other. So I have to manipulate them a little bit first in order to get that. All right. So what I could do is if I times this top one here by 3, so times them all by 3, because that's what I'd have to do, then this would become 6x, and it would be the same as this one. All right. So I'm going to do that one. So multiply the first one by 3, so that both x terms have the same coefficient. All right. So I'm going to write another equation for these two. So the 6x plus 5y equals 16 stays the same. And then what I've done is I've times all of this by 3. All right. And there's nothing wrong with doing that as long as I do it to everything on both sides. All right. So times that by 3, times that by 3, times that by 3. So every term, effectively. Now I can do what I did 2 minutes ago over here. I'm going to do that one take away that one, that take away that, and that take away that. All right. So let's label them again. So we've now got a new one, so let's call it 3. But I'm going to do 3 take away 2 to eliminate x. So the x's this time disappear. If you think last time it was the y's that disappear, so this time it's the x's. All right, so the x's have gone this time, not the y's. And 18 take away 16 is going to give you 2. All right, so y equals 2. Of course, we're not done. We now need to substitute y into one of the equations to find x. So you can choose any of these, to be honest, any of them. But yeah, I suppose you would probably want to choose the easiest one, so probably choose the top one. So 2x plus 2 lots of 2 is 2x plus 4 is equal to 6. And then rearranging it, so take away 4 from the other side gives you 2. So therefore x is going to be 1. All right, so I've got my two answers here, x equals 1 and y equals 2, and solved. All right, okay. Well, so far you'll notice that in both these two equations, or both these kind of examples, I've dealt with just positives. So you'll notice in all the equations there, they're all dealing with positives. Well, of course, that's not going to be always the case. We might have some negatives to deal with. So it's only pertinent that I kind of cover the idea of what would happen if you've got negatives. Okay, so let's have a look if you've got a negative involved. All right, so it says at the top, if the signs of the variable with the same coefficient are different, i.e. one's plus and one's minus, then you can add the two equations together. All right, so if I look at this example here, the plus 2y and minus 2y, well, when I add a 2y and a minus 2y, when I add them, they're going to disappear. All right, and that's the kind of another trick to kind of take on board, is that as long as the coefficients are the same numbers, if the signs are different, then I can add the two equations and that will eliminate them. All right, so like before, I'm going to label them. I'm going to tell the person looking at it that I'm going to add them to eliminate it, and then do exactly that. So 4x plus 3x is 7x. These two added together disappear, and 16 take away 2 is 14, leaving me with x as being 2. Okay. So like last time, we need to substitute it back in. So substitute it into either of these two equations. So we're going to go for the top one. So 4 times 2 is 8, plus 2y equals 16. So that's 8 plus 2y equals 16. Rearrange it, so 2y is equal to 8, therefore y is equal to 4. All right, so I've got my two answers, also my solution for x and y. All right. Right, last one, where maybe like the first lot is the signs are different. So I've got a plus and a minus, but then I also have different coefficients. So what I did last time is I tried to manipulate it so that I did get the number in front to be the same. So we're going to try that the same. So I'm going to take this equation and times it by 4 to get that to be 4y. Okay, all right, let's have a go at that one. So times the top one by 4. So I've got it's x now, plus 4y equals 36. You can see that there. And then the second one is the same as before. And now, because, like I said last time, because these signs are different, I'm going to add them. And again, like last time, I am writing down, telling the examiner what it is I'm doing to try and eliminate them. So when I add the two, I've got 13x here, and I've got 36 plus 3, which is 39, and then divide both sides by 13, so x is going to be 3. And then when you've done that, you're going to substitute it in, ideally the top one, because it looks easiest. So 2 times 3 is 6 plus y equals 9, so 6 plus y equals 9, and then rearrange to say that y is equals 3 also, okay? So there you go. So that's how we solve simultaneous equation by elimination. All right, so you've got to keep your eye on the signs. We've got to try and get the coefficients to be the same, and follow those processes which I've kind of gone through. All right, please do have a look at maths-school.co.uk. There's a bunch of kind of questions for you there to practice, and of course this video is there for you to kind of revisit anytime you like. All right, thanks for listening.